Okay, we're now talking about multiplying and dividing rational expressions. And multiplying and dividing rational expressions is not that different than multiplying and dividing fractions. For instance, let's look at a simple example. 6 over a squared times negative 2 over a cubed. With multiplication, we don't have to worry about the denominators being the same or anything like that. With multiplication, we just have to multiply across the top and multiply across the bottom. Therefore, this is 6 times negative 2, which is negative 12. A squared times a to the third is just a to the fifth. Negative 12, a to the fifth. And in this case, a can't equal 0. Just like in our simplified problems, we have to check for any excluded values. In this case, a is the excluded value. Let's look at another example. X minus 7 divided by x times x minus 5 divided by x plus 3. Again, we're just going to multiply across the top, multiply across the bottom. However, when we multiply across the top, keep in mind that these are like grouping symbols, so we have to do FOIL here. So we have x squared minus 12x plus 35. On the bottom, x squared plus 3x. No other cancellation can be done. We can just leave the answer like that. The only thing to include is what excluded values are there, and in this case, x cannot equal 3, x cannot equal 0. And those are our excluded values. So multiplication, again, is really just multiplying across the top, multiplying across the bottom. Now, there may be some simplifying available. Let's take a look at a slightly more complex example. X plus 5 divided by so here we have x plus 5 divided by 7x minus 21. And we're going to multiply that by 14x divided by x squared plus 3x minus 10. The easiest way to actually do this is to factor everything first, because there may be some cancellation we can do before we even start the multiplication process. Well, x plus 5 can't be factored at all, so we just leave that as x plus 5. 7x minus 21 can be 7, and then just make it x minus 3. 14x can't be factored at all. X squared plus 3x minus 10 can be factored. It's going to factor out into positive 5 and negative 2. So x minus 2, x plus 5. And there we see some cancellation. So the x plus 5 here and here, you can always cancel diagonal and up and down, just never across. 7 and 14, this becomes a 2. This is a 1 now. So our answer is 2 over x minus 3, x minus 2. You can leave it in its factored form too. You don't have to FOIL that out. Oh, actually, sorry, this is 14x up here. I forgot to transfer it from here. So this is actually 2x still. Okay, but that's a fine form. You don't have to FOIL that out. You can leave it just like that. Obviously, if it doesn't have a, if it's just x plus 5 times something, just put the x plus 5 over 1. Okay, if you get a whole polynomial, not a rational expression, but just a polynomial, you can always put that polynomial over 1 for multiplication. Let's go on to division. The nice thing about this is that the division really isn't different. There's just one added step. So let's look at x squared minus 25 divided by 4x plus 28. And we're going to divide that by x minus 5 over x squared plus 9x plus 14. Okay. The only difference between this problem and all the problems we've done so far is this division and the first step. The first step, instead of factoring, is going to be find the reciprocal of this second rational expression. So we're going to change this into x squared minus 25 over 4x plus 28. Instead of division, we can now write multiplication because we're going to find the reciprocal of the second rational expression, which just means flip it. And now we're back to doing multiplication, which is what we were doing before, so that's not bad. So now we want to factor these. Well, this is difference of squares, so it's going to factor out to x minus 5, x plus 5. This has a common factor of 4, so we can just factor out that 4, and we're left with x plus 7. Up here, 9 and 14 are going to be 2 and 7, so this is going to be x plus 2, x plus 7 is how that factors out, and x minus 5 obviously doesn't factor out at all. Okay, now we got some cancellation available, right? X minus 5, x minus 5, x plus 7, x plus 7. So we're left with x plus 5 times x plus 2 over 4. And that's the simplification. That's all the simplification we need to do. Just remember to say that x, in this case, cannot equal 7, or sorry, negative 7, and x cannot equal positive 5. Those are our excluded values. But that's the only difference. The only difference for this one is if you start with division, you have to find the reciprocal of the second rational expression, and then just do it like multiplication like we've been doing. Remember to factor and simplify first. It'll be a lot easier. Okay. Just for a vocabulary standpoint, I want to point out something. You can have something called a complex fraction, and a complex fraction looks like this. It's where you have a fraction over a fraction in this form, which is just the same as a divided by b, all divided by c over d. Right? These are the same things. This is just called a complex fraction. But it's just another way of writing this same thing here. AB divided by CD, which means it's the same as AB times D over C, which is often the way you're going to want to deal with this. You're going to want to take this and turn it into this to make it a lot easier. Okay, and that's it.